Welcome back, guys, to another redstone tutorial. Pi here. Today we're going to be talking about monostable circuits, and if you don't know what that is and somehow found this video without explicitly searching for it, that's where you convert a pulse into a single tick pulse. So we got three types here. The first is a rising edge monostable circuit, so when we press the button, that will light up over there for one pulse, as you can see, and this is a falling edge one where it lights up right before on the falling edge of the pulse. So you can see it flash there right as this unclicked. And then you've got ones that do both. So this will flash both on the rising edge and the falling edge. Perfect. So we're going to quickly go and explain how to build these and how all three work. So first, let's do the rising edge one, which is probably the one you want most, which is when something happens, make a one tick pulse out of it and then ignore everything else until it unpowers and repowers. So the first thing we want to do is just put a button connected to this redstone wire, and then that will power this block. Now you need to make sure it's pointing this way. So if you click on it and it's not pointing, this won't work anymore. Still does, actually. There's some issues with that, but apparently I don't know what I'm talking about. Either way, this redstone does actually power this piston through here. I do know what I'm talking about if I just think about it for a bit more. It'll also power that redstone repeater through the block. But if I don't have that pointing to the block, it doesn't, because it's not pointing through the block anymore. So you got to make sure it's pointing through the block. And the thing here is that basically, when this powers this block, it powers both the piston and this repeater. But once it powers the piston, the next tick the piston raises, and it no longer can go through the block to power the repeater. So the repeater only gets powered for one tick. And we can see that here. So, general idea. Redstone powers through block to repeater, but then on that same tick, the piston moves the block out of the way, so you only get one tick where this is powered and the block is here. Now the inverse, we can basically accomplish this by simply inverting the signal. So we can put a button here and then feed this into redstone here so it's automatically on, and then we place our piston here, our repeater on the other side, and then what happens is when we press this, this goes down when this unpowers. And then when this repowers, it has one tick where this is still down. The same deal here. When this powers on, it flashes. However, this powers on the falling edge of the button, rather than on the rising edge of the button. Now, so if you want to have both, where you detect both the falling edge and the rising edge, you need to... I didn't space these properly. You know what? That's okay. You need to basically combine both approaches. So we're going to place a button here. And then just our same redstone that gets powered by the button. Except this time, we're going to place our piston on top of this block. It still gets powered through this block. But instead we're going to use this block. Instead of having the redstone go through that block, this block's going to cut the redstone off. So we can again put our repeater here so it gets powered through the block. And then we can step up our redstone. And then when this block goes here, these are cut off. So you can see it's no longer displayed on the side. And so when this block moves here, it can no longer power. So there, it flashes on and flashes off. And so what happens is when this first pulses, it powers the block, powers the repeater, and we get this powered. But with the next tick, because this is powered as well at the same time as the repeater, this block moves, cutting off the power. So we only get that one tick. And then when this unpowers, the block starts moving back and the repeater makes the signal last. So you get that one tick on the way back as well, where the repeater's powered, but the block moves back. I'm going to quickly run this in slow motion so you can see it happening slowly just to understand how it works. And that's monostable circuits. Alright, as you can see here, when the button gets pressed, all the redstone turns on, and then in the next tick, the block moves over and cuts it off. When the redstone unpowers, the block starts moving, allowing the signal to go through for one tick before it turns off as well. So I hope you all enjoyed. Let me know if there's anything else you want to see, and I'll talk to you guys later. See you next time. Alright, so this is really jank what I just did here, but to set this up, I wanted to show you that these are actually not the same falling edge. They have the same rising edge, this guy as this guy, but the falling edge is slightly different. So if we press this button, you can see they appear to be happening at the same time. But this guy over here has actually a 2-tick delay before anything happens. There's 2 redstone pulses, whereas this guy only has a 1-tick delay. So you might be wondering, why are they at the same? Well, it's because this one actually occurs 1 tick earlier than this one, because this one occurs right before the piston retracts. The piston retraction is what breaks it, whereas this one occurs right after the signal resets, and then the piston moves away. So this one actually occurs on that right after the signal flips, whereas this one lights up on the last time the signal is still high. And that's why this one actually occurs 1 tick later than this one. But when I added 2 redstone torches on this side versus 1, it occurs on the same redstone tick. Anyways, hope you guys enjoyed.